In this video, I will present you a way to structure a program for dispensing application. This program solves three common problems faced with dispensing application. First problem, the position of the profile on which the robot have to do dispensing may vary. The robot have to be capable to do dispensing whatever the position of the profile. We will use the Robotiq wrist camera to solve this problem. Second problem, the dispensing trajectory have to be easy to edit. It may happen that after you complete your first program, you need to adjust some waypoints. It is necessary to have an easy way to do those adjustments. Third problem, the dispensing tool attached to the robot often comes with a lot of surrounding equipment like pipe supplying dispensing material. This equipment imposes some motion restriction to the robot. To avoid any problem, the robot should, as much as possible, keep the same tool orientation. Let's run the program and see how it solves those problems. The robot detects the position of the profile and follows the dispensing trajectory with keeping the same orientation. Now I change the profile position. The camera detects the new position of the profile and follows the dispensing trajectory with the same tool orientation. This program contains the camLocate node, which is used to detect the position of the profile. Under the camLocate is placed a relative trajectory. This trajectory is relative to the position of the profile detected by the camera. The camLocate node uses a snapshot position called profile 1. The relative trajectory uses a feature point called relative trajectory reference. The tool orientation is defined by a waypoint at the beginning of the program called tool orientation reference. The relative trajectory is defined as follows. First, I unsuppress the master folder. And I suppress the relative trajectory folder. I execute the program to bring the robot at the position of the profile detected by the camera. Now I stop the program, I go in installation, and I save the relative trajectory reference at this position. I go back in the program, I suppress the master folder and unsuppress the relative trajectory folder. Now I can define the relative trajectory starting from waypoint 1. It is important to have for all waypoints the same orientation. You can use the Robotiq Force Copilot Active Drive toolbar to place the waypoint while keeping the same tool orientation. So let's place trajectory waypoints starting from waypoint 1. I use the Active Drive toolbar and I set the mode with fixed orientation. I move the robot to waypoint 1. I save the position of waypoint 1. I use Active Drive again and move the robot to the second waypoint. I save the position of the second waypoint. Now I move the robot to the third position. And I save the position of waypoint 3. Now I move the robot to waypoint 4. And I save the position of waypoint 4. Now I can run the program and the robot will move relatively to the position of the profile detected by the camera while keeping an orientation same as tool orientation reference waypoints. The camera detects the profile position and move on the relative trajectory with the same tool orientation. Let's move the profile. The camera detects the position and the robot follows the relative trajectory with the same tool orientation. To do some modification of the relative trajectory, I repeat the following steps. I unsuppress the master setup folder and I suppress the relative trajectory folder. Now, when I will execute the program, the robot will move to the profile position detected by the camera. Depending on the profile position, the robot may have to do some extreme adjustment of the tool orientation. This orientation adjustment may not be possible with your setup. So I recommend that you execute the program at slow speed to see in which direction the robot do orientation adjustment. So here the robot take the picture of the profile and detect the position of the profile and the robot move to the profile position. You can see that the robot is rotating this way and is kind of rotating to reach a 90-degree rotation. So I will reorient my profile to avoid this rotation. So let's stop the program and run it again. The robot detects the position of the profile and move to the position of the profile detected by the camera. This time, you can see that the robot did not have to adjust that much the tool orientation. This profile orientation prevents some damage with your dispensing equipment. Now, I go to the installation menu and I save the relative trajectory reference to this position. I go back to my program, I suppress the master setup folder and unsuppress the relative trajectory folder. I move the robot to waypoint 1. Now, it's important that I keep this orientation for all waypoints. So if I add a new waypoint, I need to have this orientation. If I modify the position of one of the waypoint I already created, I need to save it in this orientation. So to keep the same orientation during the waypoint positioning or editing, I can use Active Drive with fixed orientation mode and place my points. Let's say, for example, that we want to reposition waypoint 3. So I use Active Drive and I place the robot to waypoint 3. Now I can save waypoint 3 at this position. Now I will add a new waypoint. First, I move my robot to waypoint 4. Okay. Then I will move the robot to waypoint 5. Once again, I keep the same tool orientation as waypoint 1. I can add another one and save it. I can now run the program and the relative trajectory modification will be taken into account.